Please welcome to the Dimensions of Physics. In this session, we are going to discussing about Doppler effect. Doppler effect, it is a simple phenomenon which we are regularly experiencing in our daily life. If suppose one source of the sound comes to us, we experience that the intensity of the sound is high. When it is passing away from us, we experience that the intensity of the sound is low. This is the phenomenon we call it Doppler effect. And we comes to know that the frequency is changing with the respect of motion of the observer, either motion of the source of the sound. Okay, in this class we are going to derive the formula for when the observer is stationary and the source of the sound is moving. For that, let us consider an observer here who is rest in position with respect of medium. Here we are considering the source of the sound S1 whose velocity is Vs, and we are assuming that the distance between observer and the source is L. Okay, and one other assumption we are taking that this observer has a detector, and this detector counts the every crest which releases from the source of the sound. Okay, it suppose at the t is equals to t naught time, it suppose the source of the sound emits a one crest, and this crest travels in the medium of the air and reaches to the observer at the time t is equals to t1. Then how can we find out the t1 here? T1 is equals to the distance it traveled by the velocity of the medium, because this crest is traveled in the medium, so that we are taking the velocity of medium here. So T1 is equals to L by V. This is the equation 1. Then at the same time, when it is the when the source of the sound emits a crest, it simultaneously it moves forward and it reaches the S2 position. S2 position at the time t is equals to T1, and again it releases the second crest. The second crest is also travels in the medium and reaches to the observer at t is equals to T2 time. Then how can we find out the T2 here? T2 is equals to, here we know that at the S1 position it emits one crest. At the S2 position it releases the second crest. We know that the time taken in two successive crests we call it time period. So that the time taken from S1 to S2 is to reach T0 here, the time period, and we know the velocity of the source Vs. So the distance traveled from S1 to S2 is Vs into T0. So from this we can write the T2, we can find out the T2. For the source of the sound, it moves from S1 to S2. The time taken for the S1 to S2 is T0 plus this crest travels from S2 to observer. So we have to find out the distance between S2 to O here. So for that, the distance traveled from S2 to S1 is Vs T0 by V. This is the time taken for the travel from S2 to S1, plus again the time taken to travel from S1 to observer is L by V. This is the time taken for the second crest reaches to the observer. Same way, it and the t is equals to T3 time. This source of the sound reaches to the S3 position, and it emits again one another crest, the third crest. It travels in the medium of the air and reaches to the observer. Okay, what is the time taken for the third crest reaches to the observer? Let us find. T3 is equals to, same way the distance traveled from S1 to the time taken for the travel from S1 to S2 is T0, from S2 to S3 T0. Again, this third crest travels from S3 to O. So, we know that S3 to S2, Vs T0 by V. Here also Vs T0 by V. Again, from S2 to S1, Vs T0 by V plus S1 to observer, L by V. From this we can write 2 T0 plus 2 Vs T0 by V plus L by V. This is the time taken for the third crest reaches to the observer. It is goes on like that, and when it is n plus 1th crest, emits the source when releases n plus 1th crest, it reaches the observer at the time t n plus 1. How can we write? From this we can write n T0 plus n Vs T0 by V plus L by V. Then what is the time interval it takes from the initial crest to n plus 1th crest? We have to find. For that we can write Tn plus 1 minus T1, that is equals to n T0 plus n Vs T0 by V plus L by V minus T1. T1 is equals to L by V. Cancellate L by V, L by V. This is the time interval. Which takes from the initial crest to n plus 1th crest. So we are denoting with the time interval here, capital T. From this we can write n T0 plus n Vs T0 by V. From this we can write n T0 into 1 plus Vs by V. Okay, this is the time taken for the n crest reaches to the observer. Then what is the single crest time taken for the single crest reaches to the observer? Let us find. For that we can divide with the n. Okay, cancellate n and n here. T is equals to T0 1 plus Vs by V. Okay, this is the time taken for the observer. When source is moving, observer is stationary. Then what is the frequency? How can we find the frequency? We know that T is equals to 1 by F. 1 by F is equals to 1 by F0 into 1 plus Vs by V. From this we can simplify. F is equals to F0 into 1 plus Vs by V to the power of minus 1. If we apply the binomial theorem for this 1 plus Vs by V to the power of minus 1, binomial theorem. Vertical F is equals to F0. If we apply the binomial theorem, we will get 1 minus Vs by V. Okay. This is the formula for when observer is stationary and the source is moving. Okay.